today. It should go by quickly. It really should. There's really not a whole lot here. This is the domain and range of absolute value. You guys already had an IXL lesson on domain and range earlier last 6 weeks. I don't remember what it was, but basically just looked at points on a graph. You probably remember doing that one. There was only a handful of kids who never did that lesson. So 90% of my students did it. But here we're actually looking at the domain and range of graphs, not just points plotted, domain and range of graphs. When you talk about domain, what values are you interested in? X. Domain is the X values. And it is read left to right on a graph. How about range? Y values. And it is read bottom to top. On a graph. So X values, and man, I really need to work on my handwriting, but probably not going to fix it. X values are read left to right on a graph, and your Y values are read from the bottom up on a graph. Now, we have a function in front of us. I shrunk it so not all your numbers show up. But does anybody know what this is the graph of? This is the mother function. Y equals what? It is a mother function. It's a V. It's in the title. It's the absolute value of X. And the question up here only wants domain, but we're going to say and range on all of these. We're going to do both of them, just so we can go over it. Now, when you're reading graphs, you don't have like points plotted. You just have to think about what's going to happen. Will this graph run forever left? Yes. You see, notice it's going up, but it keeps going left forever if you were to trace out with your pencil. Will it go forever right? All right, so the idea when we look at this graph is the graph runs forever left, which we actually call negative infinity. But we're not going to talk about that just yet. And forever right, which we actually call positive infinity. Graph runs forever left to negative infinity and forever right to positive infinity. Is there a single value of X that this graph doesn't touch? Anna says no, it's everything. We're not worried about range. I'm actually talking about the domain first. Anna says no, it's everything. Think of the biggest number you can think of. It's that number. Think of the smallest number you can think of. It's that number. The domain on this one is actually all real numbers. And I know you've seen and talked about that in Algebra 1. The domain is everything, all real numbers. In fact, all absolute value graphs have a domain of all real numbers. And I mean that. There's no exception to this rule. All absolute value graphs have a domain of all real numbers. There's a notation. Oh, XER, there's a notation, negative infinity to positive infinity. There's also XER. X is an element of real. But IXL doesn't say that. IXL says all real numbers. That's not read all real hashtags, by the way. It's all real numbers. Do not be that 2020 kid who reads that as all real hashtags. That has been the notation for number for 100+ years, okay? It didn't just come around because of hashtag and Twitter. Now, we talk about range. Wish I hadn't used all that room right there. Whatever. There is you can't see it here, but there is a solid dot right there, and that is the smallest value of y. You guys agree? Doesn't it kind of run up forever from there on? So what do you know about y? That everything equals 0. Now, IXL is going to use what's called set builder notation. You're going to see a curly bracket. You're going to see y because you're talking about y, and then a straight up bar. This little piece is actually read all values of y such that. Then you have the restriction, y is greater than or equal to 0. Now I said on domain, it's always going to be all real numbers. Range will change. Domain, though, is all real numbers, and this thing is multiple choice, and just knowing domain is all real numbers makes each and every question 50-50. Because I sat here and did the thing. It takes like 3 minutes. But it makes every question 50-50, just knowing that domain is what? All real numbers for absolute value. And if you don't believe me, as we do a couple of these, you'll see. We start talking about the domain and range of this one. I want domain and range. Does it run forever left? Does it run forever right? What's the domain? All real numbers. Range. This graph has shifted left, but that just affects values of x. It actually has no effect on this one. What's the smallest value of y? 0. Okay. Does it rise forever? Yes, it rises to what we call infinity. So Grant, what's the range? I says y is greater than or equal to 0. Domain and range are kind of funny. They are ridiculously simple concepts that some kids struggle with for a while, but then once they struggle with it, they kind of want to hit themselves in the face for struggling with it. I mean that. It is something that is really ridiculously simple. I think the problem is you're having to read graphs. What you got, Chandler? That's exactly how it is on IXL. Curly bracket, all values of y such that y is greater than or equal to 0. And nothing in IXL uses an open dot. So you're always looking at an inequality symbol with an equal sign in it. Always. Always. Okay?
But still, I have the first one. It's just a line.
That's just straight up bar.
Why do you have to add the first line?
Because of what it means. This piece right there means in words all values of y such that this is true. That's just what it means. I didn't write the notation. You'd have to ask the original inventor of the notation. I'm sure they're long and gone by now. Huh? Of course they can be upside down. We may not, we'll have one that will at least look in a calculator that's upside down. I know that. But yeah, they can be upside down. All right. Spencer, what's the domain of this one? Logan, what's the domain of this one? Alex, what's the domain of this one? Domain. All real numbers. It's friggin' absolute value, kids. If it looks like a V, what's the domain? All real numbers. Now, Alex, let's talk about what you were saying. I don't even know where you got -4. Let's not talk about what you were saying. Peep house. What's the range?
The y is greater than or equal to -7.
That's half of it.
In the y line. Yeah, the y.
Don't forget your Y bar. And what's that all encapsulated in?
It's squiggly lines.
Yeah, those curly braces is actually what they're called.
Curly braces.
Yeah, they're called curly braces.
I do the weird shit.
They're called curly braces. At least that's what I've always been told they're called. Now, who needs to talk about this whole y greater than or equal to -7? No.
Unless it's upside down.
It's gonna be less than. It's gonna be less than. It's never just gonna be greater than or less than.
Nope, these are all solid dots.
Okay.
The only time you would see just a greater than symbol is if you saw an open dot. But that's not in this section. All right, let's do another one of these. Spencer, what's the domain? Thank you. Do you know why? I know, but does the graph run forever left? So you could count backwards for all of your life, couldn't you? Does the graph run forever right? So you could count forwards for the rest of your life, couldn't you? If you lived an eternally long life, could you count every number?
That would suck.
Yes, that's all you do, but yes, you could count every number. Hence,
Losing your place.
hence all real numbers.
You have to restart.
All real numbers. That's why it's everything. All right, I know, Sean, I know you know the range. I do. But I'm curious if others do. Chandler, what's the range of that function? Y bar, y greater than or equal to 2. Do you guys agree with Chandler? Don't forget your curly braces. Now that probably needs to be talked about still, but only if you ask, am I going to tell? Does anybody need to know why it's y greater than or equal to 2? Because you start here and you rise forever. That's why it's 2 or more. Remember, y is the axis that goes up and down. As you move up, they'll shift this thing around trying to make it harder. But it's really not a big deal. Domain and range of this one. Logan, what's the domain? All real numbers. Of course, IXL actually says numbers. They don't use the number symbol. All real numbers. All right, now Alex, this graph starts right here. Okay, and then you work your way up. So what's the range? What about y compared to -7? What's y's relationship to that -7? It's going up. Remember, the graph is rising. So what is y compared to that -7? I'm just going to pick a point on the graph, Alex. Right there, y is -2. Is that more than -7? If I pick a point right here, that's where y is -2. Is -2 more than -7? Yes. What's our relationship to -7? If I pick a point right here, y is 2. Is 2 more than -7? That's on the graph. So what's your relationship to -7? More or less? What are you? Greater. But this is a solid dot right here that exists. So what does that imply as well? In addition to greater, can y be -7 right here? That implies equality. Greater or equal. Don't forget your y bar. Don't forget your curly braces. Now here's why you got your calculator out. You might hit the on button. I'll show you how to do it in the calculator, and I know you don't have TI-84s at home, but I'll show you how to use a particular website as well. You can do a little of both. Huh? It'll still work. I don't care if it's an 81, it'll still work. Yeah, there's one right here. But just bring that one up here so I can look at it. Anyways, kids, turn your calculators on. 83 will work just fine. I know we gotta wait on Piva House a second. D13 is the same lesson except they give you equations. I know you know how to graph these by hand. Well, you're supposed to. I'm not asking you to do that. Although if you know what you're doing, it doesn't take long. You can just kind of visualize it. If I factor out of 2, that becomes twice x plus 6. That means shift left 6. And from that vertex, what's the slope? 2. So rise 2, run 1. Yeah. I'm not asking you to graph by hand, though. Should you? Probably. Do you have to? No. There's an entire lesson on doing these graphs. You can figure it out there. But I graphed it by hand, took 30 seconds. It's not hard to do. And when I do these, I don't graph it by hand. I graph it up here in my head. I don't bother grabbing a calculator. I just think about it in my head. Not everybody can do that. But anyways, this is what technology is for. For those of you who don't know what's going on, you can at least use a graphing calculator. Now, do you remember how to actually graph stuff on a calculator? Go to y equals. Anyways, this one has something in here already, so I'm going to hit the clear button. Yours may or may not have something in there, I don't know, but I cleared it out. Now, the equation starts with the absolute value signs. And if you look at your keypad, you don't actually see absolute value bars. They don't exist on the keypad. All right? So the absolute value bars, I'm going to make a little note here, are found by pressing Math, scrolling to NUM for number. So I hit Math, all right, then I hit the right arrow. That gets me to NUM. And ABS does not stand for anti-lock brakes because it's a calculator. What do you think ABS stands for? Absolute value. Okay, I'm going back. Are you at y equals, Grant? Press the Math button. It's the 4th run down. Hit the right arrow to NUM and ABS, so you press enter. Now, your calculator may show the absolute value bars. It may show ABS. It doesn't matter. What are we going to type inside that? 2x plus 12, the original equation. And you don't have to close off the parentheses because this is the only thing going on, but you probably should. Bro, how did you become a junior?
I'm just asking, like, I didn't know.
You have eggs?
Yes,
I put 2 and then I hit the X button.
Okay, well, usually I mess it up and you
Oh, it's your name.
I'm just picking on you, Grant. There's always one kid who asks that every single year.
I'm just making sure I know how to do it. That way when I get somewhere where you're not there, I can do it.
Anyways, I know in the past the teacher just told you to hit graph. I'm not a fan of that because these calculators are used by different kids all day long. You should hit zoom and then scroll down. You can either do a zoom square or zoom 6. I always do zoom 6. Zoom square makes a lot of sense, but I always do zoom 6.
They're invalid. I knew what they were.
So what do you do after you run your product? I get it. You hit graph.
What does yours say?
Invalid.
Zoom 6.
You click on Zoom, scroll down to Zoom 6 and hit enter.
What is this?
Zoom 6.
Or sorry, Trey, what was your question?
Figured
it out? Don't do zoom fit. Don't do zoom fit. Never do zoom
Mine
fit.
doesn't have zoom 6.
You don't have a TI?
Are you saying the 6th one?
Yes.
Oh, zoom standard.
Zoom standard, zoom 6.
I-
Never ever use zoom fit. Never use it.
Wow, what's wrong with this shit?
Because it doesn't always set the window
Zoom
properly.
4, zoom 6.
Just trust the guy who's been doing this for 10 years and has taught 1,200 kids. Never, ever use zoom fit. Never, ever use zoom fit. Ever. Don't use it. Sooner or later, it's going to cause a problem with you.
What is it?
Because it doesn't always set the windows right. It doesn't always work. Anyways, that's how you use a TI-84, okay? Now, the other option we can do, and we'll do both problems both ways, we can go to a site called desmos.com. If you want to play along on your phone, that's fine. I don't care. Open that up for me. It's desmos.com. desmos.com. And I'm going to click on graphing calculator. Now, I don't know exactly what it looks like on a phone because I don't think I've ever used it on a phone. But I think Anna's got it up and it looks like she already has a keypad up. I'm on a PC. I actually have to press this button right here to pull up the keypad. You may not have to.
Graphing calculator?
Huh?
Oh,
Yeah, just click graphing calculator. The phone may already have this keypad up. I don't know. Anyways, if you look above ABCs, you see the absolute value symbol. You just click that. Then the original equation was 2x plus 12. So you type that in. And there you go. You got a graph to look at. And that's the only difference between D13 and D12. In D13, you either need to be thinking about the graph in your head, which is where I'd love for you to be, or you need to be asking technology to do it for you. And by the way, when you ask technology to do something, why don't you try to make sense of the graph it is showing you? Don't just accept it. Try to make sense of why it works that way. That's going to help you long term. You should be questioning why a lot. You really should be. Why is it? Why does it look this way? Try to make the connection. But it looks the same thing as I drew, doesn't it? Looks the same thing as the TI-84 showed us, so we know we're doing it right. Let me switch back over. We'll look at the next one. We'll do this with both Desmos and a TI-84. Now, this one actually does something different than the rest of everything else on this page. What's different? Scale factor is already outside, and it's what? Negative. How's this thing open? Does it open up or is it open down? It opens down.
They go negative.
Yeah. This would be a less than equal to situation. Now, if I was doing this by hand, what I would do is I'd fall 5, because that says minus 5. I'd plot a point, and from that point, what would I do? Go down 2 and over 1, both sides, because it's absolute value, and absolute values are V's. But if you've been doing your IXL, you already know that. That's what it looks like. Now, with that in front of me, what's the domain? All real numbers. What's the range? Ty says y is less than or equal to negative 5. Of course, you need your y bar and you need your curly braces. Why do you say less than or equal to negative 5 this time? Because it opens down, it falls forever. It's everything less. I'm just gonna use the TI-84. You can type that thing in Desmo, it's pretty simple. So the first thing I see, and I know that you're not typing along, you're gonna be that kid who doesn't understand what I did. I see a -2, I'm literally going to type in -2, not -2, -2. TI-84 has a different key for that. There's a negative symbol, it's right by the enter key. Now what am I ready for? Math absolute value. Math, num, ABS. X. Do I need to close the parentheses here? Yes. Why? Because there's more, right? Because there's more, and I don't want it encapsulated all together. Then a zoom how? 6 or 5. 5 is kind of cool in that it actually squares the window. Because the TI-84 screen is rectangular, it's not squared. But zoom square squares the window, makes it look like it should if you were doing it by hand. But it's the same exact graph, so everything's going to be the same. I actually intended for you to get more time, but you got 10 minutes, kids, and I know you got some IXL to do. I know you do. I haven't given you a work day yet. But you should have 2 things, if I'm thinking right. 3 things now. There's 3 IXL assignments. And this one can be taken to a 90, both of them. Because the difficulty in the questions never changes. That was D12 and D13. You can take them to a 90.